Hello everyone, welcome to Soumya Tutorials class BCA second semester NEP syllabus data structure using C. This is the session 3, chapter 2. The chapter name is stack. First, let me know about what is a stack. A stack is an ordered collection of an items where addition of a new items and removal of an existing items is always takes place at the same time. This end is commonly referred to as the top of the stack. In the stack, the end of opposite to a top, this end we can call it as a base. In the stack, the most recently added item is one that is in the position to be removed first. This ordering principle is called last in, first out basis. So that the stack we can also call it as last in, first out. Once again, I'll repeat the definition. A stack is an ordered collection of an items where addition of a new items and removal of an existing item is always takes place at the same end. This end is commonly referred to as top of the stack. So here, these are all some of the real life examples of the stack. And this diagram which shows that the concept of the stack. In this example, a stack it consisting of the four elements which are 1, 2, 3, 4. All the elements are inserted into the stack in the form of the last in, first out basis. So first the 1 is to be inserted into the stack, then 2 is inserted into the stack, and 3 is inserted into the stack, and 4 is inserted into the stack. Then the next element is 5. The process of inserting into the stack, that is the process of new elements are to be inserted into the stack. This process is called push. And the process of the removing an element from this stack, this process is called pop. There are the two processes are to be present in the stack. That is, the first operation is push and the second operation is a pop. And these are all the real life examples of the stack. First example is stack of coins. Second example is stack of plates. Third example is can of tennis ball. And fourth example is stack of books. In all the example, the one by one, for example, is a coins. Here, the first coins is inserted, then second coin is inserted, third coin is inserted, fourth coin is inserted, and fifth coin is inserted. These all the coins are inserted in the basis of the last in first out concept. So the one more is the stack of plates. So here is that the first coin is inserted, the second one, third one, fourth, and fifth. So these are all that is inserted in the concept of the last in first out basis. So ಇಲ್ಲಿರುವಂತ ಪ್ರತಿಯೊಂದು ರಿಯಲ್ ಲೈಫ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಕೂಡ ಒಂದೊಂದೇ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಇನ್ಸರ್ಟ್ ಮಾಡಿದೀವಿ ಅಂಡ್ ದ ಲಾಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಈಸ್ ಟು ಬಿ ರಿಮೂವ್ಡ್ ಫಸ್ಟ್. ಸೊ ಇದಕ್ಕಿಂತ ಹೆಚ್ಚಾಗಿ ನಾವು ಇನ್ನೂ ಎಕ್ಸಾಂಪಲ್ ಹೇಳಬೇಕು ಅಂದ್ರೆ ನಮ್ಮ ಹ್ಯಾಂಡ್ ಓಕೆ, ನಮ್ಮ ಹ್ಯಾಂಡ್ ಅಲ್ಲಿ ನಾವು ಬ್ಯಾಂಗಲ್ಸ್ ಅನ್ನ ಹಾಕೋತಾ ಹೋಗ್ತೀವಿ. ಸೊ ಒಂದ್ ಸೈಡ್ ಇಂದ ನಾವು ಬ್ಯಾಂಗಲ್ಸ್ ಅನ್ನ ಇನ್ಸರ್ಟ್ ಮಾಡಬಹುದು, ಮತ್ತೆ ಅದೇ ಸೈಡ್ ಇಂದಾನೆ ನಾವು ಬ್ಯಾಂಗಲ್ಸ್ ಅನ್ನ ಹೊರಗೆ ತೆಗಿಬಹುದು ಅಲ್ವಾ. ದಿಸ್ ಇಸ್ ಒನ್ ರಿಯಲ್ ಲೈಫ್ ಎಕ್ಸಾಂಪಲ್. ಸೊ ದ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಟು ಬಿ ಇನ್ಸರ್ಟೆಡ್ ಅಟ್ ಒನ್ ಎಂಡ್ and deleted at the same end. That end we can call it as a top of the stack. This is a process is occurred in the concept of stack. The stack we can also call it as last in first out. Then we move on to the next slide. Representation of stacks in memory. The representation of a stack in the memory can be done in two ways. The first way is static representation using arrays, Second way is dynamic representation using linked list. Representation of a stack using arrays. This is the first way to representing the stack. The stack can be represented using one-dimensional array. What is an array? An array is an ordered collection of an elements. The array is an ordered collection of homogeneous elements. So in this, the elements are to be inserted at one end and deleted at the same end in the concept of the stack. So this is a representation, we can call it as the representation of a stack using arrays. The array is an ordered collection of an homogeneous elements. So that the items into the stack are to be in the sequential order from first location of the memory block. Here, the pointer, that name we can call it as a top. The top, it contains the location of the top element of the stack. And the one more variable is maxstk. This is the max stock. It contains the maximum number of an element that can be in the stored in the stack. There are the two words is there. One is a top pointer and one more is a maximum stack and one more is an items. So here is the diagrammatic representation. So this is the diagrammatic representation of a stack. Here elements are to be inserted at one end and this is the shows that the stack grows in this direction. So this is a pointer, that's the top of the stack and these are all the indexes. If we attempting to add a new element beyond the maximum size, we will encounter a stack is an overflow condition. Similarly, you can't remove the elements beyond the base of the stack. In such cases is that we will reach the underflow condition. So that here there are the two conditions are to be occur. One is a condition is called this condition. The top which is equal to maximum stack. It is indicated that the stack is a full. And one more condition is that the top which is equal to null. So this is the condition indicates that the stack is an empty or the stack is an underflow condition. So in the representation of the stack using the arrays, it contains only a two condition. The one condition is that the top which is equal to maximum stack. It indicates that the stack is a full. So why we have to conditions are to be applied in this stack? Because if we attempted to add a new element beyond the maximum size, we will encounter that the stack is an overflow condition. So then there is a no element are to be inserted at this condition are to be in the true statement. So then one more condition is top which is equal to null. It is indicated that the stack is an empty because we cannot remove the elements beyond the base of a stack. If such is in the cases, we will reach the stack underflow condition. So that there are the two important conditions in the representation of the stack here is that the top which is equal to maximum stack and the top which is equal to null. Then the second representation of the stack is linked list representation of the stack. The size of the array needs to be fixed to store the items into the stack. If the stack is full, we cannot insert an additional item into the stack so that it gives an overflow exception. But as in the case of the linked list, we can increasing the size at the runtime or a execution time by creating the new nodes. So it is better to implement the stack data structure using the linked list data structure. Here is the diagrammatic representation of the linked list representation of the stack. So first the node has to be created, then the new element are to be inserted, that is 21. Then one more node is created, the element are to be inserted at this node, that value is 34. This is attached to an end of this node. Then one more node, that is 78. The 78 is an element are to be inserted into this node and it is attached to the previous node. Then one more node is created. So that node contains a 42 element. It is attached to an previous element. Then one more node is created. Here the 10 element are to be inserted at the node and it is attached to this previous node. So here every node it contains the two different parts. The first part it is called information field. Second part it is an link field. Information it contains the data. All the nodes it contain the two different part. First part it contains the information field and the second part it contains the link field. The information field it contains the data and the link field it contains address of the next node. This is a linked list representation of the stack. The advantage of the linked list representation in a stack here is that we can increasing the size of the stack at the runtime by creating the new node. So it is better to implement the stack data structure using the linked list representation. Then we move on to the next slide, operations on stack. So there are the 6 different operations are to be performed on the stack. First operation is stack. Stack, it is an operation or it is a process. It creates a new stack. This stack, it is an empty. It needs a no parameters and it returns on the empty stack. So this is a first operation that is a stack. A stack, it creates a new stack that is an empty. It needs the no parameters and returns an the empty stack. One more is push. Push, it is a process. It adds a new item to the top of the stack. This process we can call it as a push operation. The push, it needs a parameter name we can call it as a item. Third one, pop. A pop, it's a process of removing the top item from the stack. This process is called pop. Fourth one, peek. Peek is an operation. It returns the top item from the stack, but it does not removing it. It only displaying the top item from the stack. Next is empty. Is empty, it is an operation which is used for it test whether the stack is empty or not. The last one is size. Size, it returns the number of items are present in the stack. For example, stack it contains only a 4 elements 1, 2, 3 and 4. When the size function are to be returned, the result is that 4 because this stack it contains the number of items are a 4 elements only. So that the result is that the size which is equal to 4 only. This is one example. These are all the 6 different operations are to be performed on the stack. This is a very important algorithm for an stack, the push operation, and one more is the pop operation. So what is a push operation? The process of adding the one element into the stack. It is represented by an operation. This is called as push operation. The push is the operation of adding the new element into the stack. This is we can call it as push operation. In the push operation, we have to adding the new element into the topmost position of the stack. Here is your algorithm. Algorithm for push operation is it contains the 3 parameters like stack, top and one more is item. Here the stack is an array with the number of elements and top is a pointer to the top of the element of an array and item. The new item is to be inserted. So we need the 3 parameters stack, top and item. So these are all the steps for writing an algorithm for the push operation. The first step is that first we have to checking the overflow condition. The condition is that if the top is double equal to n minus 1, n is the number of elements. So if the top is double equal to n minus 1, when this condition is true, the stack is full or a stack is an overflow. If the condition is false, go to the step 2 statement. The step 2 is that when the condition is false, go to the step 2, the top is incremented by the top position. Then we have to inserting the new element into the stack. In the step 2, the top pointer are to be incremented, that is an top equal to top plus 1. After an incrementing the top, then we have to inserting the new item into the stack, so that we writing this step is the stack of top which is equal to item. Here is the new item which is inserted into the stack of this top pointer position. So then step 4 is return. So these are all the sum of the steps for writing the push operation. So here is an example or the diagrammatic representation of the push operation. The first, it is on the empty stack. Here the top pointer which is equal to -1. The top which is initially -1. So this is an empty stack. Then we have to inserting the new element into the stack. Element is A. A is an element which is inserting into the stack. Then the top point is incremented by the 1. So that the top which is equal to -1 plus 1 which is equal to 0. So that the top which is incremented by the pointer 1. So that the top position is 0. Then the next is the next element B. The process of adding the new element into the stack. The element is B. Then here the top which is incremented by the pointer 1, so that the top which is equal to 1 now. Then go to the next step. Here the element is C. We have to adding the new element into the stack. The element is C. Here the top which is incremented by the value 1, so that the top which is equal to 2. Then the stack the stack diagram is that the element is D. Here we have to adding the new element into the stack. The element is D. The D is inserted into the stack. The top pointer is incremented by the 1. The top value is 3 now. So here the maximum size is only 4. So that the stack is full now. This is a operation. The process of adding the element into the stack, that operation we can call it as a push operation. Then go to the second operation. This is also very important. Pop operation. The process of deleting the one element from the stack is represented by an operation. We can call it as a pop operation. Here also the algorithm, the pop is an operation. It contains the 3 arguments: stack, top and item. The stack is an array with n elements. Top is a pointer, the top of the stack, and item. The item is to be deleted. So first step, if the top which is equal to null. This is a condition which is used for checking an underflow condition. In this condition is true. It prints the statement the stack is an underflow or the stack is an empty. When this condition is true, the statement are to be displayed. When the condition is false, go to this step. Here, the last element are to be copied and it is stored in the item. Copy the top element and it is stored in variable item. Then it is deleted. After a deletion, then go to the step 3. The top pointer is decremented by the 1. So top which is equal to top minus 1. Then return. The first step is that you have to check in the condition underflow so that top which is equal to null. If the condition is true, it print the statement that stack is an empty. When the condition is false, then go to this step. Here, the top element ought to be copied and it is stored in the variable item. Then it is deleted. Then go to the step 3. Top is, after deleting an element, the top value is decremented by the 1 so that the top is equal to top minus 1. Then return the algorithm. So this is a process we can call it as the pop operation. The pop is an operation. It is a process of deleting the topmost element from the stack. So this is the diagrammatic representation of any stack. So this is a stack is full statement. It contains the 4 elements, that is 10, 20, 12 and 33. Here the top value is 3 now. Then the first pop operation, the topmost element are to be deleted so that in this diagram the 33 is deleted and the top pointer is decremented by the 1. Here the top which is equal to 2 now. Then go to the next diagram. Here the one more element 12, the topmost element is deleted. So this after deletion, the top which is decremented by the value 1 so that the top is 1 now. Then go to this statement, this diagram. Here the topmost element 20 is deleted from this position and the top pointer is decremented by the value. So the top which is equal to 0 now. Then the last diagram here, the topmost element is a 10. This 10 is also deleted and the top value is decremented by the 1 so that the top which is equal to minus 1. This is all the process we can call it as a pop operation. Pop is a operation which is used for deleting an topmost element from the stack. So this is we can call it as a pop operation. Then we move on to the next slide, applications of stack. So there are the number of applications of an stack here is that first application is the stack is a application. It is used to reverse a word. You push a given a word into the stack letter by letter and then pop the letter from the stack. So this is a reverse in a word. Second application is undo mechanism in the text editor. We have to enter in the any text. If the any mistaken are to be occurred, we have to undo in the text editor. So this is the second application. Third one, backtracking. What's the backtracking? This is a process when you need to access the most recent data item in the series of elements. Once you reach the dead end, then you must backtrack. This process is called backtracking. Then language processing. The compiler is a language processor. Here, the syntax checks for matching the braces in the implemented by using the stack. So this is a language processing. Here, the stack is also used in this concept. Then one more, conversion of decimal number to a binary. Sorry, conversion of the decimal number into the binary. For example, a 15 is one decimal number which is converted to the binary. The result is that 1111. Then one more example, 7 is one decimal number which is converted to the binary. The values which are 111. The one more example, 8 is a number which is converted to the binary. The values which are 1, 0, 0, 0, 1 and 3 zeros. So these are all to be converted. How it is converted? The decimal number which is divided by the value 2. After and the calculating, we have to entering the element from the last to and the first. That means and MSB2 and the LSB. So this is, we can call it as the conversion of the decimal number to the binary. Then conversion of infix expression into the prefix or an postfix. Then quicksort. The last one, runtime memory management. These are all some of the applications of an stack. So these are all the some of the important questions from this session. What is a stack? Explain the stack representation using the arrays, and explain the dynamic representation using linked list, and write a note down operations of a stack, and write an algorithm for push and pop operation in a stack. This is very important, push and pop operation. The last one, explain applications of stack. These are all the some of the very important questions from this session. Thank you. If you like my videos, please do subscribe to my channel, Soumya Tutorials, and click on the bell icon for the notification of the new videos. Thank you.